Welcome to springlib.
We're given this function f, where m and n are positive integers. So the first observation here is that the function essentially depends on the sum of n and n. So let's call s m plus n, so that we see that f of n is equal to s minus 1 that multiplies s minus 2 divided by 2 plus m. Now both m and n are positive integers, so they start from 1. So s must be equal to 2. And if s is fixed, then m can only be, well, 1, 2, all the way up to s minus 1. So from now on, we imagine s to be fixed and to change m, and therefore n will depend directly on m. So n is just going to be s minus m, so that's a way. Now this function here is just s minus 1 times s minus 2 divided by 2 plus m. And this function, as m varies from 1 to s minus 1, the value of the function can only range from s minus 1, s minus 2 divided by 2 plus 1, all the way up to s minus 1, s minus 2 divided by 2 plus s minus 1. So essentially, if s is fixed and m varies from 1 to s minus 1, we're covering all the integers from s minus 1, s minus 2 divided by 2 plus 1 to s minus 1, s minus 2 divided by 2 plus s minus 1. So we have that range covered. Now what we need to understand is what happens when s changes. So let's call g s of m, so s is fixed and m is a variable. So g s of m is defined as f of m s minus m, where s is a fixed number greater or equal than 2, and m is allowed to vary between 1 and s minus 1. So the first case is when s is equal to 2 and m is equal to 1, so the lowest possible values. So g2 computed in 1 is by definition f of 1, 1, and that's by definition of f 1 times 0 divided by 2 plus 1, so that's just 1. So good, the function g in the smallest possible value is 1. Now to understand what happens when we change s, remember that we imagine fixing s and varying m. So we ask ourselves what happens when m reaches the maximum value it can be, so s minus 1, and we want to go up by 1. So let's compute g of s plus 1 in 1. So this is f of 1s, and you replace the values, and this becomes s minus 1 that multiplies s divided by 2 plus 1. Right, so this is the value of g s plus 1, 1. Now, g of s in s minus 1 is instead f of s minus 1, 1. You plug in the values. You do a bit of algebra here, where we're just using the distributive property. All right, and now you see that this is exactly s minus 1 divided by 2. Because the minus 2 s minus 1 divided by 2 gets cancelled out by the s minus 1. All right, so we see that g of s plus 1, 1 is equal to gs s minus 1 plus 1. So essentially, when we reach the maximum value m can be for a fixed s, so s minus 1, then the following number is exactly the value that we would obtain by increasing s by 1 and putting m to the minimum. So to make it more clear, we start with 1, which we've seen is g2 in 1, and then 1 is the maximum value that can be before 2. So next we need to use the formula down here to step up by 1, and that becomes g of 3 computed in 1. Now m, so the 1 is allowed to vary up to 2, And so that's G3 of 2, and that's exactly 1 more than G3 of 1. And now again, 2 is the maximum value it can be before 3, so we need to use the formula again. So by increasing by 1, we can change the 3 into a 4 and reset m to the minimum value. So we have G4 of 1, which is 1 more than G3 of 2. And again, now m can increase, so we have G4 of 2, then we can increase again by 1 to get G4 of 3. And now 3 is the maximum value before 4. So by using the formula, we reset the m to 1 and we increase s, and so on. And essentially, you see that repeating this process, we are every time stepping up by 1, but we started with 1. So all these values are all different, and they cover the entirety of the positive numbers. And therefore, f is a bijection.